Everyone, welcome back. So this time we're going to go over an example of how to use the method of joints. Okay, you're probably freaking out. You're like, there's no way we can do this. But you're wrong. You can. It's actually not that hard. This involves math. You're old in me. So as normal, I'm going to give you a plan. We'll let you go off on your own and try to do this. And if you fail, come back. If you succeed, come back just to make sure that you really did succeed. So first off, what we're going to do, check if there are any zero force members. Spoiler alert, there are. Then analyze pin D and then pin A. Okay, right here, pin D, pin A. I think it's kind of cheating. It's giving you way too much help there. Oh, come on. Wait a second. It's giving you way too much information. This is not a plan. This is how to solve the problem. Okay, and it says, why if this problem you have to find the external reaction before solving the problem? Okay, I've given you way too much help now. But, as always, you're going to go off, and in 3, 2, 1, you're going to return. We're going to look at this together. So, let's do this problem, which you've given way too much help with. So, first off, I'm not even going to, well, we'll do it the way it says, and then we can come back and do that differently. Because I might have different ways I want to do this. And we're going to look at this. Okay, so we see right here at point D, we've got two forces, force AD and force CD. Okay, 45-degree angles, both pointing down. Pretty simple. And we can use our sum of the forces in the x direction and the y direction to solve. Two equations, two unknowns, a little bit of algebra we can solve. Which gives us that force AD is this, force CD is 318 and negative 318. One's in tension, one's in compression. We also realized from earlier that this right here, that's a zero force member. Which means we only really have to find that last little force right here at pin A. We need to know what that is. If we look at it really hard, what we'll see is that at pin A, we already know what force AD is. So we can solve for our other two unknowns. So we set up an equation. We get sum of the forces in the x direction. We can solve for force AB. And we know, since this is a zero force member, that force AB is going to be same as the force BC. And from that we can go. And yes, you could have analyzed joint C instead of joint A. Now, this required you to do algebra, which I am always against. Why do algebra if you don't need algebra? Okay, look, everything's algebra, but solving a system of equations is no fun. So let me show you how you could have done it without any equations. Sorry, systems equations. I don't want to get it. You just can't magically know the number. I divine the answer is 5. There's no help for that. But one way you should probably do is always try to find the reaction forces to begin with. At least one of them. I love rolling supports. Usually rolling supports are where magic happens. So I want to figure out what this is. So I'm going to make my free body diagram first of the entire thing with just the reaction forces. I've got AY right there. I've got CY and CX. Okay, CY, CX, AY. And first off, I can see that CX is going to be, well, it's going to be 450 pounds that direction. Only one force in the Y direction. Second thing I can do, sorry, there's my 450, right there. Is I'm going to take the sum of the moments around this point, which lets me see that I have, okay, sum of the moments around point C is equal to, and that would be 8 times AY. That's turning one direction, and then opposite direction, yes, would be minus 450 times 4 feet. And that's equal to 0. Okay. So we do the math. This is 1800 divided by 8. And of course I have to do math. So let me get my calculator out right here and see what the answer is. 1800 divided by 8. So AY is equal to 225 pounds. Okay, now here's why I like this. Because earlier I had to solve two equations simultaneously right here, which is fine, you can do that, but I like to avoid that. So now let's redraw our free body diagram at point A. I've got AY, which is 225 pounds. I've got AB, which I don't know what direction it is. I'm just going to say force AB going here. And I've got force AD going up. And hopefully you're already seeing why I like this. This is 45 degrees. So AY is going straight up in the Y direction. Guess what? Only AD has a Y component. Therefore, I can solve for it. So if I draw this one, the Y component, that's opposite over hypotenuse. So 225 pounds must be equal to force AD sine of 45. And that would get me the exact same answer without having to do any simultaneous solving or making sure I plug my variables correctly. Each person has their own. Some people just I know how to solve equations, I'm just going to set up the equations and solve them. That's fine. But there are ways where you can avoid a whole lot of algebra by being careful about which equations you do first. So don't forget that. Remember that there are always ways to make these problems easy, at least most of the time. And look for those. It can help you. Because with that, we can solve for force AB. We get force AB and BC. And we can come up here and we can solve again without having to do any simultaneous equations. So I hope this helps you. Hope you enjoyed it. I'll see all of you next time. Bye-bye.